Hey friends, welcome back to Civil Engineering Mastery. I have received many queries regarding column reinforcement arrangements, like how do we arrange the number of bars into the specified size of the column. For example, if we have a 300 by 450 size of column, how do we arrange the reinforcement bars? According to the area of steel, we need to arrive the number of bars, and how do we arrange the number of bars in a proper manner. So in this video, let's discuss in detail about how do we arrange the reinforcement bars according to the size of the column, and what is the spacing we need to provide for ties, and what is the spacing between two main reinforcement. Everything we'll discuss in detail according to the code IS 456-2000. So without further delay, let's begin. First, let's look into the basic arrangement of the reinforcement details of column. Consider this column. Here, these 8 bars are the longitudinal bars or main bars, main reinforcement of column. And in order to hold this main reinforcement in position, we need to provide the ties, lateral ties. So these are the ties. In this column, we have 2 ties. One is covering all the main reinforcement and another tie is provided inside. It is covering only these 4 bars. Similarly, if you take this column, we have 8 main bars or longitudinal bars. We have one tie, this is one tie which is covering the outer bars, and one more tie is covering the inner 4 bars. Consider this column. Here also we have many main bars, and then we are having ties here. This is one tie, and this is one tie, and this is one tie. Let's see in this review section. Here, if you see, this is the main bar or longitudinal bar. So to cover this one, or to hold these main bars, the lateral ties are provided. If you see here, the ties are provided in some distance, some spacing throughout the column. So let me tell you about how much spacing we need to provide between ties according to IS 456-2000. Also, let's understand the concept of why do we provide longitudinal bars and lateral ties. First, let's discuss about the longitudinal bar. As we all know that column is a compression member, so its predominant function is to resist the compressive force. So to resist the compressive force, we provide longitudinal bars or main bars. Now the question is, why do we provide the lateral ties? Lateral ties are provided in order to resist the column reinforcement, that is the main bar or longitudinal bars, from buckling. To prevent buckling of longitudinal bar or main bar, the lateral ties are provided. In addition to that, the lateral ties are resisting the shear force, so it helps to prevent the shear failure. Also, it helps to hold the main bars in position to avoid buckling of column. So this is the basic concept. Why do we provide main bars as well as lateral ties in columns? Now let's discuss what is the minimum distance between individual bar. That means distance between longitudinal bars. I'm not talking about the lateral ties. You have to be clear. Here I'm talking about the longitudinal bars or main bars. We know how many number of bars we get according to the area of the reinforcement, that we need to divide according to the size of the column. But the problem is, how do we divide that one, and what is the minimum spacing we need to provide between the longitudinal bars or main bars? So this is the class which is given in IS 456-2000, minimum distance between individual bars. The following shall apply for spacing of bars. The horizontal distance between two parallel main reinforcing bars, you have to notify that it is for main reinforcement. Main reinforcing bars shall usually not less than the greatest of the following. Let's see what are all the factors. First one is the diameter of bar if the diameters are equal. Second one is the diameter of the larger bar if the diameters are unequal. 5 mm more than the nominal maximum size of coarse aggregate. So you have to understand the diameter of the bar if the diameters are equal, diameter of the larger bar if the diameters are unequal, and 5 mm more than the nominal maximum size of coarse aggregate. So usually we consider 20 mm size of the coarse aggregate. If the size of the coarse aggregate is 20 mm, then in addition to that we need to add 5 mm more than that, so we'll get 25 mm. So among these three, whichever is greater, we have to use that one. So the spacing shall not be less than the greatest of the following. So in addition to this, they had given that this does not preclude the use of larger size of aggregates beyond the congested reinforcement in the same member. The size of aggregates may be reduced around congested reinforcement to comply with this provision. Even if it is more congested, in that place we can even reduce the size of the aggregate. For example, let's consider the diameter of the bar is 25 mm. Size of aggregate is 20 mm. Along with that, we need to add 5 mm extra. Then it becomes 25 mm. So in this case, we have to provide the spacing between bars is 25 mm. So this is the greatest. So minimum we need to provide this much spacing. Now you can have a question that why do we need to provide this much spacing specifically? Here there is one more point is there. Greater horizontal distance than the minimum specified in A, class A, that is this one, should be provided wherever possible. So wherever possible we can apply this one. However, when needle vibrators are used, the horizontal distance between bars of a group may be reduced to 2/3 the nominal maximum size of coarse aggregate, provided that sufficient space is left between group of bars to enable the vibrator to be immersed. So this is the major point, because if we provide very less spacing, it will not be sufficient to immerse the vibrator to vibrate the concrete. We need to provide the proper spacing between the reinforcement bars in order to immerse the vibrator, and then we need to properly vibrate the concrete. Why do we need to vibrate the concrete? What happens if we don't vibrate the concrete properly? The air voids present in the concrete will not be removed if we don't vibrate the concrete properly. That is called honeycombing. That creates many problems, even that tend to weaken the structure and will not get the proper finishing of the structure. So that is why we need to provide proper spacing between the reinforcement bars. According to the code, it is 25 mm as per the size of the aggregate plus 5 mm more. That is possible theoretically, but practically it is always good practice to keep 75 mm as the minimum spacing between two reinforcement bars to vibrate the concrete properly. Next, let's look into the reinforcement details according to the IS 456-2000. Longitudinal reinforcement, that is main bar. The cross-sectional area of longitudinal reinforcement shall not be less than 0.8%, not more than 6% of the gross cross-sectional area of the column. So minimum reinforcement percentage we need to provide 0.8% area of steel, and maximum it is 6%. Here in note they have mentioned that the use of 6% reinforcement may involve practical difficulties in placing and compacting of concrete. As I told you before, vibrating is very difficult if we place 6% of reinforcement. So hence lower percentage is recommended, where bars from the column below have to be lapped with those in the column under consideration. The percentage of steel shall usually not exceed 4%. So we need to provide maximum percentage of column reinforcement as 4%. Minimum number of longitudinal bar provided in column shall be 4 in rectangular and 6 in circular column. So this is the minimum number of bars we need to provide, 4 in rectangular column and 6 in circular column. So the bar shall not be less than 12 mm in diameter. Next, let's look into pitch and diameter of lateral ties. The pitch of transverse reinforcement, that is called lateral ties, shall not be more than the least of the following distance. So whichever is minimum among these three, we need to use that one. First one is least lateral dimension of the compression member, that is column. Least lateral dimension of the column, and 16 times the smallest diameter of the longitudinal reinforcement bar, and last one is 300 mm. So we have to consider these three things to provide the spacing between lateral ties. So we need to use these three criteria to fix the spacing between lateral ties. Now let me show you few columns with the dimension and the number of bars. How do we arrange that? First, let's see this column. Column size is 750 by 200. 200 is the width and 750 is the depth. So here they had given 14 number of 25 mm dia bar. Here 14 represents the number of bars and Y25 represents the dia of the bar, and this is the ties, lateral ties. Lateral ties is 8 mm dia bar, while 8 represents the dia of bar at the rate of 200 mm center to center. See 14 bars how they have arranged here. In the longer dimension, that is 750 mm, they have 7 bars, and in this side they have 2 bars. In this way they have arranged. Now let's see the lateral ties arrangement. Here we have 3 lateral ties and 1 link. See, this is one tie which is covering all the outer bars, and this is one tie which is covering the inner 4 bars. This side also we have similar arrangement. This tie is covering these 4 bars, and in between the center we have only one link. This we should call as a link, and these are all ties. Here you can see this is one tie which is the master tie. We can call it as master tie, and these two are the smaller ties, and this is the link which is only connecting 2 bars. Let's find out the spacing between bars. In this line we have 7 number of bars, and the depth of the column is 750 mm. So 750 minus, we need to deduct the cover on both sides, this side and this side as well. So 40 minus 40 is the cover for column. We get 670 mm. That we need to divide by the spacing. 7 number of bar means we get 6 spacing. So divided by 6 we get 111.6 mm. So this much spacing we get between these 2 bars. So we have seen in the IS code, minimum we need to provide according to the diameter of the bar, or else we need to give the coarse aggregate size, maximum aggregate size plus 5 mm. That comes around 25 mm. Here we have the diameter of the bar also 25 mm. So theoretically we need to provide this much, but practically we have a practice of providing 75 mm. Here we have 111.6 mm, which is more than sufficient to place the vibrator to vibrate the concrete. So this is how you have to find out the spacing between bars. Here let me tell you about the lateral tie spacing, 200 mm center to center. You can ask how we get this 200 mm center to center. As I told you before, as per the IS code, we have 3 criteria. One is least lateral dimension of the column. Second one is 16 times the smallest diameter of the longitudinal bar, and last one is 300 mm. Among these 3, whichever is the lesser value, we need to use that as a lateral tie spacing. So here 200 mm is the least lateral dimension of the column. 16 times dia, 16 times 25, that is more than 200 mm, and last criteria is 300 mm. So 16 times 25 and 300 mm is more than the least lateral dimension of the column. So that is why we need to use 200 mm as spacing for lateral ties in this column. Next, let's look into this column C2, 600 by 200. Main reinforcement is 12 numbers of 25 mm dia, and tie spacing is 8 mm at 200 mm center to center. Now you can see the reinforcement arrangement. 6 number of bars is provided in the direction of 600 mm, and here also. So totally 12 number of bars, 12 number of 25 mm dia bar. Let's look into the links. See, one master link and then 2 smaller links. This is one link and this is one link. The tie spacing, lateral tie spacing is similar to column C1. As I have explained you, the 3 criteria, the same applied here also. Next, column C3 is of same size of C2, but the reinforcement is different. See here, 12 number of bars only, but the diameter of the bar is 20 mm. Instead of 25 mm, here we have 20 mm dia of bar, and the tie spacing is same, 8 mm at 200 mm center to center. So the arrangement looks like column C2 only. Next, here let's see the column C5. The size of the column is 600 by 300. Here we have 2 different diameters of bar. 6 number of 25 mm dia bar plus 8 number of 20 mm dia bar, and the lateral tie spacing is 8 mm at 300 mm center to center. Let's look into the arrangement. See, first 6 number of 25 mm dia bar. Always we have to arrange the larger dia bar in the outer area of the column. If you see here, only in the outer area we have provided the larger dia of bar, that is 25 mm dia bar, and inside we had given the smaller dia bar, that is 20 mm. Outer 6 number of 25 mm dia bar. Inside it is 8 number of 20 mm dia bar. Let's look into the tie spacing, that is 8 mm at 300 mm center to center. You should remember the three criteria. First one is least lateral dimension of the column, that is 300 mm, and 16 times the smallest dia of longitudinal bar. So here 20 mm, 16 multiplied by 20, that is also more than 300, and last criteria is 300 mm. So among these three, least we need to consider, so that is why it is considered as 300 mm spacing. Let's look into the ties arrangement. So we have one master tie, this is the master tie, and we have two smaller ties which is connecting these four main bar, and here also four main bar, and one link we have that is connecting these two bars. Next, column 6, that is having the size of 600 by 600 mm. So here longitudinal bar is 20 number of bars of 16 mm dia. 20 number of bars we need to provide. The diameter is 16 mm. Here the spacing for lateral ties is 8 mm at 250 mm center to center. So let's look into the arrangement. Here we don't have two different dia bars, only we have 16 mm dia bar. So in this direction 6 numbers, in this direction 6 numbers. Since it is a square column, so all around the column we have provided the longitudinal bar. Let's look into the ties spacing. So here first criteria is least lateral dimension. Here the least dimension is 600 mm, that is more than 300 mm. Next one is 16 times the dia of the smallest longitudinal bar, that is 16 mm. So 16 times 60, which is 256 mm, and the last one is 300 mm. So among these three we have 256 is the lesser value, that is why here it is provided as 250 mm as spacing for lateral ties. Let's look into the lateral ties arrangement. See, this one is the master tie and we have four smaller ties. So in this way we have to arrange the reinforcement. Next, column C7, which is of 300 by 300 size. The longitudinal bar is 8 number of 16 mm dia bar, and the spacing for lateral ties is 8 mm at 250 mm center to center. See, here the arrangement is very simple. Since it is a square column, we have provided 8 number of 16 mm dia bar. The lateral tie spacing is similar to this column as I have explained you. Let's look into the arrangement, lateral tie arrangement. See, we have one master tie and we have one smaller tie. So that is connecting this way. Next one is 600 by 300. Here we have 14 number of 20 mm dia bar, and the spacing for lateral ties is 8 mm at 250 mm center to center. Next one is column C8, that is 600 by 300. The similar size we have discussed already, but only in this case we have two different diameter of bar, but here we have same dia of bar. Longitudinal bar 14 number of bars, 20 mm dia, and tie spacing is 8 mm at 300 mm center to center. So the arrangement also looks similar to that column only. Next, let's see this C1A, that is of 750 by 200. Here we have 16 number of 25 mm dia bar, and tie spacing is 8 mm at 200 mm center to center. Here we have ties arrangement. This is the master tie, and we have three smaller ties. Since we have 16 number of 25 mm dia bar, we have to provide the arrangement like this. Next one is column 5A, that is of 600 by 300 mm size. This arrangement also we have discussed earlier. Next, let's see 750 by 450. Here 18 number of 20 mm dia bar, and the tie spacing is 8 mm at 300 mm center to center. So let's look into the main bar arrangement. In 750, in this direction we have 7 number of bars, and here 4 number of bars. Since the diameter is same, there is no need to provide like a larger bar in the outer direction. Next, let's look into the tie arrangement. This is the master tie which is covering the outer bars, and we have three smaller ties. This one. See here, this is one smaller tie, this is one smaller tie, and this is one smaller tie. In the horizontal direction also we have one smaller tie, and in the middle we have one link which is covering these two bars. Next one is column 6A, that is 900 by 600. Here we have 22 number of 20 mm dia bar, and the tie spacing is 8 mm at 300 mm center to center. Here we have provided in the longer direction, that is 900 mm, 8 number of bars are provided in the longer direction. This side it is 6 bars, and in the shorter direction 6 number of bars. So we have the tie arrangement arrangement like this. This is the master tie and we have smaller ties, 3 number of smaller ties. This is one tie, this is one tie, and here we have one tie, and in the horizontal direction also we have one tie, which is connecting only these 4 bars, and in the middle part we have one link which is connecting the 2 bars. Next column C10, that is of size 450 by 300 mm. We have 10 number of 20 mm dia bar. Tie spacing is 8 mm at 300 mm center to center. So this is very simple arrangement. 4 number of bars this side 3 number of bars. Let's look into the tie arrangement. This is the master tie and this is smaller tie, and we have one link in the middle. So friends, I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. If you like this video, please do share it with your friends and hit the like button. Also, super thanks button has been enabled in our channel. If you really like the content, if the content is very useful to you, if you want to support the channel, please log into your email and click on the super thanks button below this video and pay some amount to support the channel. And don't forget to subscribe this channel for more videos. Thank you for watching.